Hello, everybody, and welcome to our YouTube stream. Good evening or good morning, wherever you are watching from. We are live at NASA's Marshall Space Flight Center in Huntsville, Alabama. My name is Alyssa Lee. I'm the social media lead for Marshall, and I will be your host tonight as we settle in for one of the most exciting sky events of the year, the Perseids Meteor Shower. If you're familiar with NASA's Marshall Space Flight Center, you know that the agency relies on us for propulsion systems, engineering expertise, and launch vehicles, like the SLS rocket that launches the Artemis missions. Tonight, however, we're introducing you to another incredible team at Marshall, NASA's Meteoroid Environment Office, or MEO, as we like to call it. They're the group who studies, tracks, and helps us understand meteors entering Earth's atmosphere, as well as meteoroids and comets further out in space. So while most of us look up at the night sky for fun or curiosity, they're looking up to gather data and learn more about these space rocks. And their work also helps NASA in mission planning to protect people, spacecraft, and instruments from damage. We're here with you now because tonight is the peak of the Perseids Meteor Shower, one of the best annual meteor showers you could witness without any special equipment, just your eyes. But for those of you who aren't in good viewing locations, we've got you covered. During the stream, we are going to be looking at live views from one of our meteor cameras right here at Marshall, with several meteor experts joining us to talk about the science behind what you're seeing. To give a brief background, the Perseid meteor shower happens when Earth runs into a stream of dust left behind by the comet Swift-Tuttle. When that dust burns up in our atmosphere, it creates the meteors that you will see tonight. So if you're excited to watch for meteors with us, put a comet emoji in the chat to let us know. Here in Huntsville, our local time is just after 11 p.m. on the night of August 12th. For us, the Perseids will hit their peak in the early morning hours of August 13th. These meteors are typically bright and frequent, but even if we do get cloud cover over Huntsville like we're having right now, we have a jam-packed agenda for you. So go ahead, get comfy, grab a snack, maybe some caffeine if you're planning to stay up late with us. We are settling in for a great night of sky watching. Now, speaking of experts, I think it's time we bring in one of the best. Bill Cook is the lead of our Meteoroid Environment Office at Marshall. If you've ever heard NASA talk about meteor showers, chances are Bill and his team had something to do with the data behind it. Bill's going to talk more about what the Perseids are, why they happen, what you can expect to see tonight, and hopefully share some stories from his career studying meteors for NASA. Feel free to ask him questions in the chat, and we'll get to as many as we can throughout the stream. Bill, welcome to the stream. Before we get distracted by meteors, can you tell us more about yourself and your career?
Oh, well, I've been doing astronomy ever since I was a kid. I was one of those young little nerds that liked science. So, when I was growing up, I had chemistry sets and geology sets and telescopes and all sorts of things. And I just gravitated towards science. And when I got older, I decided, hey, I want to make it a career. So I went to college, got my degrees in astronomy, and ended up here in NASA. And I've been here at NASA doing meteor stuff for over 30 years now.
That's amazing. Can you tell us what your team does at the MEO?
Well, the MEO we do have a very important mission, because when we have spacecraft and crews up in space, meteoroids pose a big threat, and our job is to help protect the spacecraft and those crews from meteoroid impacts. So we do things like forecast meteor showers or help designers place shields over critical components. So our main job is focusing on the meteoroid hazard to vehicles and crews and helping to mitigate that so our missions can be successful.
I love that. Your work is so important to what we do here. Tonight, we're going to be looking at our meteor camera right here at our observatory at Marshall. Can you tell us more about that meteor camera and maybe show us what it looks like?
Sure. We have one right here. This is an all-sky meteor camera. And as you can tell, it's a very fancy piece of technology. It's basically got a low light level video camera here, and there's a protective dome over it, and the low light level video camera captures the meteors. and sends a signal to a computer where software will go through that video stream and detect the meteors for us. And these type are all sky cameras. They see the entire sky, and they're specifically designed to observe bright meteors or fireballs, which are meteors brighter than the planet Venus. And we have, I think at last count, 15 of these scattered across the country, helping us monitor the night sky for fireballs.
Awesome. I'm excited to get into looking at that a little later. Thank you so much, Bill. So now let's talk a little bit about what is coming up during this stream, because we have got a full night planned for you. Obviously, the main event is the Perseids, and we'll be keeping an eye on our meteor camera feed throughout the evening. Anytime something streaks across the screen, we'll try and pause to talk about it. But also throughout the stream, we're going to chat with a few other experts to talk about some fun Perseid facts, the difference between meteors, comets, and asteroids, and how NASA observes these other near-Earth objects. And of course, we want the stream to be as interactive as possible. So remember, if you have questions about the Perseids, meteors in general, and how NASA tracks them, drop those in the chat. All right, let's pull up our meteor camera now and see what's happening above Huntsville. If you're new to watching meteor cameras, don't worry, we will make sure to point them out as we see them. But if something fast streaks across the frame, that's more than likely going to be a meteor. If you do spot one before we do, let us know in the chat. Now keep in mind, we are not quite at the peak of the Perseids yet, so we may only see a few meteors to start off the night. We are also obviously having a storm right now, but we do expect those clouds to hopefully push away soon, and we will pick up those Perseids as the watch party continues. So, Bill, is there anything you want to mention on the camera feed right now while this storm's happening?
Yes, it's a perfect example of Murphy's Law. Whenever there's a peak of a meteor shower, it's going to cloud up on you. This is an all-sky camera, just like I showed, and hopefully when it clears up, we will begin to see Perseids there. Right now, we're getting a lot of rain and lightning, though.
The lightning is cool to witness, though. It's been pretty exciting. While we're waiting for those clouds to clear, I'm going to ask you a few questions here. So are these meteors that we're going to be seeing tonight all going to be Perseids?
No, there'll be meteors from the sporadic background. In any night, you'll be able to see about 6 or 7 meteors an hour, and that's just due from junk we run randomly into. It's not associated with a meteor shower. And there will also be meteors from other showers less intense than the Perseids, like the Capricornid meteor shower. So not every meteor you'll see tonight will be Perseids, but most of them will be. The vast majority will be.
Perfect. And I know that you mentioned that this is part of the All Sky Network. We actually have, I think you said 15 cameras in that network. But we actually have a camera that we could switch to right now at New Mexico State that's looking a little better cloud-wise. So I think we're looking at that right now. Is there anything on this camera that you want to talk about, Bill, before we move into any more questions?
Well, it doesn't look like it's raining. There are a little bit of clouds there. But yeah, this camera is identical to the one we have in Huntsville, and it's a little bit earlier in New Mexico. They're an hour later than we are in terms of time zone. So, you know, things are just ramping up in New Mexico. It's about 10 o'clock there, and the Perseid radiant doesn't rise until about 11. So we're still waiting on meteors to start showing up in New Mexico.
Perfect. Well, I'm seeing a lot of excitement in the chat. We love it, so keep it up. Now, our local peak time, like you mentioned, in Huntsville is around 4 a.m. So we still have a few hours before that high activity window. For viewers that want to watch the peak themselves, is that peak time the same for each time zone, Bill, or is it different?
Yeah, the peak time is influenced by how high the radiant is in your sky, and it gets best about 4 o'clock in the morning, which is right before dawn begins. So the peak time depends on how high Perseus is in your sky, and that's about 4 a.m. local time, no matter where you are in the United States.
Perfect. Well, speaking of local peak times, I'd love to know where our viewers are watching from. So let us know where you're watching from in the chat. And if you plan on going outside at any point tonight to see the Perseids for yourself, or maybe you already have seen some, the Perseids may be peaking tonight, but this shower has actually been active since late July. Is that correct, Bill?
Yes, we started seeing Perseids in the meteor cameras about July 27th this year.
Perfect. Why are meteor showers active around the same date?
Oh, that's because we run into their debris trails the same time every year
Hmm.
as Earth goes in its orbit around the sun. So, we encounter the Perseids this time uh, this year, and the Earth will go around the sun once and we'll smack into it again in mid-August next year. And like with the Geminid stream, we hit that in the middle of December every year. It's just where these trails intersect Earth that determines when we hit them. But we always come back and hit them again in the following years.
Gotcha. That makes a lot of sense. Well, before my curiosity gets the better of me, let me see what questions we have from viewers. Dante Blankenship 6213 has asked, given that the camera is a digital system, how sensitive is it compared to a human eye?
This camera can see fireballs, which are bright meteors, about as bright as the planet Venus. We may get one about as bright as Jupiter. Your eye can detect meteors about, I would say, 30 times fainter than what these cameras can see. Now, we do have smaller cameras that can see faint meteors, but these all-sky systems see only the bright ones. So your eye is more sensitive than this all-sky camera system.
All right. At Anna has asked, why is it called the Perseids?
Because the radiant, the direction the meteors appear to come from, is in the constellation of Perseus. And meteor showers always take their name from the constellation that they appear to come from, where their radiant's located. So Perseids come from the constellation of Perseus, Leonids come from the constellation of Leo, Geminids come from the constellation of Gemini. So that's how meteor showers get their names.
Gotcha. All right, I'll ask you one more. Why can't we see meteors during the day?
Well, because it's too bright for them. But there are daytime meteor showers. We pick them up on meteor radars. And sometimes you do see meteors during the day. We do get very bright fireballs. There was one over New England earlier this year in March that was very spectacular. So sometimes you do see in the day, they just got to be really bright to stand out against the bright sky.
Hmm. I hope we get to see some fireballs tonight. I've been watching this meteor cam for a little bit. I haven't seen any myself, but I'm not the expert. Have you seen any, Bill?
No.
Okay, perfect. I was making sure that I wasn't missing any. Now, we've been talking a lot about meteors, and your team has Meteoroid in the title. Can you explain the difference between a meteoroid, a meteor, and a meteorite?
Sure.
I know these are easy to get confused, so.
Yeah, a meteoroid is a bit of rock and ice out in space. So the things we protect spacecraft and astronauts against are called meteoroids because they're out in space. When that little bitty piece of rock or ice hits the atmosphere and burns up, it leaves a streak of light we call a meteor. And that streak of light is the meteor. We don't call the little piece of rock and ice the meteor. It refers to the streak of light. And a meteor is the same thing as a shooting star. They're both the same thing. And if anything survives to the ground, so if you have a really big piece of rock that hits the atmosphere, some parts of that may make it to the ground, and those pieces on the ground are called meteorites. So in space, it's a meteoroid. When it hits the atmosphere and leaves a streak of light, it's called a meteor, and anything hitting the ground is a meteorite.
I love that lesson. It's so crazy to me that we could see these meteors from so far away. But the Perseids do not produce meteorites. But I know some of our sporadic meteors can, and I think you have some meteorites to show us, right?
Sure. We have a couple here. And yes, so if you will look, the meteorite on the left is from a very famous location. It's from Meteor Crater or Barringer Crater out in Arizona, near Winslow, Arizona, and it's an iron meteorite. So meteor crater is about 1 kilometer across, and it's what happens when a a small asteroid, a large meteoroid, hits the ground and made of iron. It excavated that big crater, and there are pieces of it, and that's a piece from meteor crater. It's an it's an iron meteorite. It looks kind of orangish.
Mm-hmm.
And on the right is a piece of the Chelyabinsk meteorite, which hit the atmosphere back in 2013 and created a very brilliant fireball over Russia. And you can see it kind of looks like a piece of charcoal.
Yeah.
And it's not an iron meteorite, it's a stony. It's what we call an ordinary chondrite, which are very common. And like I say, if you saw this on the ground, it looked like a piece of charcoal.
Yeah.
You probably wouldn't think it was really unusual at all. But this is a piece of Chelyabinsk from Russia.
That's amazing. Those are very cool, Bill. Thank you for bringing them in. If you're just now joining us, we are watching for Perseids on our Meteor camera. This view we have here is from New Mexico State University. But these Meteor cameras aren't just for our enjoyment. Bill, can you talk through what your office does with the data from these cameras?
Yeah, so I mentioned one of our jobs is to generate meteor shower forecasts. And the data from these cameras help us verify those forecasts, because if you produce a forecast, you want to know how well you did. So we take those forecasts and compare them to the data from these cameras and see how well we did, and we use that data to improve our next meteor shower forecast. So these cameras provide the data we use to validate our meteor shower forecast.
Amazing. Well, I know Perseids are known for going fast. We've hopefully are going to see some tonight. So I feel like if I blink, I'm going to miss one. So I keep looking over at the camera that we have here. Is speed something you can track in your office? Like, can you tell how fast these meteors are actually going? And if so, how?
Sure, because our meteor cameras are set up so that some of them are close enough, they're in clusters, that we can triangulate and measure their trajectories and speeds. So we can tell how fast they're moving, where they burn up, where they hit the atmosphere, all sorts of things about them. And in the case of the Perseids, we know they all move at roughly the same speed, which is 132,000 miles per hour. So pretty
Wow.
fast, even for meteors.
Yes. You know what else is moving fast, Bill, is this chat. So I'm going to take a few more viewer questions while we're waiting to spot some meteors. But keep an eye on that meteor cam for me, Bill. I don't want to miss any. So while we're watching, let's take Renee Claude 33345 has asked, what is your favorite fact about meteors?
My favorite fact about meteors, NASA likes sending missions to other planets and asteroids and stuff, and studying them. Meteors are neat because they're like little pieces of the universe coming to us.
Aw,
So as they burn up in the atmosphere, we can study them. So I don't need a spacecraft to study meteors. I can just sit and wait for them to hit the atmosphere and study them then.
I love that answer. That's so good. I'll ask you one more. This kind of goes along with it, but what's the best meteor shower that you have ever seen?
It would have to be the Leonid meteor storm of 2001. And, people think the Perseids are great when you see about 50 per hour. And in that meteor storm, there were over 2,000 meteors per hour.
Wow.
The sky was filled with fireballs. So the Leonid meteor storm of 2001 is the absolute best meteor shower I've ever seen.
That's amazing. Well, thank you for answering those questions. I do have another question of my own here. The Perseids are famous for producing fireballs, like we've talked about. Can you explain what a fireball is and what makes a meteor classify as a fireball?
Sure, a fireball is a bright meteor, and actually, technically, a fireball is a meteor brighter than the planet Venus. So if there are any amateurs astronomers on the chat, the fireball, it has to be brighter than magnitude -4. That's a fireball. And it's also the same as a bolide. You'll hear people talk about bolides. Bolides and fireballs are the same thing. Bolide just sounds fancier.
Gotcha. Well, fireballs are something I know your team is very familiar with. For you guys watching at home, whenever a significant fireball lights up the sky, the MEO actually alerts the public of this. They utilize eyewitness reports, gather and verify the data, and then share those results on a dedicated NASA website for everyone to see where recent fireballs were detected across the country. For those of you that are on Facebook and X, you could follow at NASA Space Alerts, and then that is where we post fireball sightings as they happen. So if you've ever seen a huge meteor streak across the sky and you're wondering, was that real? You could check at NASA Space Alerts or the Fireball website and confirm it. With that said, let's jump back into the Perseids. Keep those questions coming. I'm going to be looking for some good ones now to ask Bill. While I am gathering some more of those, Bill, have you spotted anything on our meteor camera that you want to point out?
Not yet, but again, the radiant isn't very high. But I've been keeping an eye on it. I hadn't seen anything yet.
Yeah, we're still a few hours away from that peak, but hopefully they'll pick up, and hopefully the storm over Huntsville will go away. Right now, we're looking at the New Mexico State University camera. They're having a little less clouds than we are. All right, I'm going to take a few more questions for you, Bill. At Antonio Perez 096 has asked, how many meteors are typically in a shower?
Oh, 11 billion. They're lots. I really don't know how to answer that because the Earth just captures part of the stream. But, you know, a typical, all right, so let me put it this way. The Perseids, we have about 60,000 meteors in our fireball database, and the Perseids account for about 4,500 of those, which is a lot. So there are a lot of fireballs in the Perseid stream.
Wow, that's amazing. Kind of on a similar, I guess this isn't a similar question, but I want to know the answer as well. Quiet Castle has asked, what is the largest meteor ever recorded? Do you know the answer to that, Bill?
Well, so technically the largest meteor ever recorded would be a 1-meter meteor, and we see those all the time because anything larger than a meter in diameter, boulder size, is considered an asteroid. And of course, asteroids are pretty big. I mean, they go all the way up to dwarf planets like Ceres, which are hundreds of miles across. But as far as meteoroids are concerned, the upper limit is 1 meter. After that, it becomes an asteroid.
Very interesting. All right, let me see if I can find one more question here to ask you. Let me see if you know this. What recent scientific advancements, if any, are a direct result of observing the Perseids?
It's a good question. Recent scientific advances is a direct result of observing the Perseids. I'll have to think about that.
Okay.
That's a good one.
I like that question too. All right, while you think about that, I do know that we have one of our members of your team has actually been behind the scenes looking at our other all-sky cameras, those ones we don't have live feeds of, but we can get playbacks of and imagery from them. And she has been collecting a few that we have seen on those other cameras, so I'd love to pull up some of those now. Oh yeah, there's a meteor.
Yep. So what you're seeing on this feed are meteors, and it looks like from the past couple of days, or actually even tonight, excuse me, from Ohio, Alleghenies in Pennsylvania, and here's Hiram in Ohio. Yeah. So you're seeing meteors from the Midwest whiz across the sky there. And of course, since it's a replay, we've got a nice little tracking box on the meteors. There was a nice Perseid. Yeah. That was a nice one.
Those are awesome. Wow.
And you'll notice they're appearing across anywhere in the sky. They can appear anywhere in the sky. This is why if you observe meteors, you need to look up and take in as much sky as possible because they can appear anywhere.
They can. I noticed on one of these clips, there's something going by slower than the meteor. Is that a plane that we can see?
Yes.
Okay, that one, yeah.
Yes, that's an aircraft.
Okay, perfect. Yeah, these Perseids go really fast. This is exciting footage to see. And it does look like these are happening from tonight. So I'm hoping we'll see some live a little later. But while we wait for our cameras to pick back up and for the clouds to move, I'd love to show you guys a little video that we have prepared that can give you basically a little 101, a little breakdown of the Perseids. Like I said, these Perseids are known for going fast, so we have some fast facts for you prepared. I'd love to take a look at that now if we have it ready. And this is hopefully going to give you a little breakdown of the Perseids and our topic of the night.
Perseids travel at about 133,000 miles per hour, 214,000 kilometers, which is faster than a bolt of lightning. Here are 10 more fast facts about the Perseids. Perseids are one of the oldest observed meteor showers, with records of them dating back 2,000 years ago. The Perseids are debris left over from the comet Swift-Tuttle, which the Earth travels through once a year. Swift-Tuttle is more than 15 miles wide. At their peak, the Perseids can produce up to 50 meteors per hour under dark, clear skies. The shower is called the Perseids because from a skywatcher's perspective, the meteors appear to radiate from the constellation Perseus. The Perseids are active for about 6 weeks, from mid-July through late August, and the peak happens when Earth hits the densest part of the debris stream. The Perseids are one of the most photographed meteor showers, thanks to their brightness, frequency, and timing during warm summer nights. Each meteor you see is a bit of comet dust that's been traveling through space for hundreds or even thousands of years before hitting our atmosphere. Though humans have been watching the Perseids for more than 2,000 years, they were first recognized as an annual meteor shower in 1835. Although we see debris from Swift-Tuttle annually, the comet only orbits us about once every 133 years. It last passed through the inner solar system in 1992 and won't return until 2126. The Perseids are famous for producing fireballs, which are exceptionally bright meteors, but most of the particles creating them are smaller than a grain of sand.
That was a great video to give us a little 101 of the Perseids and what we can expect to see tonight. So now I want to go to a full screen view of New Mexico State University's meteor camera. That's what we're looking at now. We are going to take a moment to look at this full screen. Please let us know if you spot any meteors in the chat, and we'll be back to talk about them in just a few moments. All right, you guys have been looking at a live view of one of our meteor cams at New Mexico State University. That camera is part of a system that we use here at NASA's Marshall Space Flight Center in Huntsville, Alabama to look for meteors. My name is Alyssa Lee. I'm hosting this Perseids Watch stream tonight. I am the social media lead for Marshall, and we are so excited to have you joining us. But I think it's time that we introduce a very special guest now. We're going to see if we can tune back into our meteor camera a little later on tonight when we get some more those clouds out of the way, basically. But joining us now is someone that the MEO here at Marshall have worked with for literally decades. Dr. Peter Brown from Western University in Canada. Bill, who is the lead of our Meteoroid Environment Office, has worked with Peter since he was a graduate student writing his dissertation, which was actually on two of the most famous meteor showers out there, the Perseids and the Leonids. So when it comes to meteor showers, he's as expert as it gets. NASA Marshall and Western University have had a formal partnership since the year 2000, and Peter has been a key part of that relationship. The university operates CMOR, the Canadian Meteor Orbit Radar, which has been running since the late 1990s. CMOR is one of the world's primary meteor radars, and our teams share data constantly. The university also operates a similar all-sky fireball network like the one we run at Marshall, and our partnership allows us to study meteors from multiple locations across North America. So, with all of that said, Peter, thank you so much for joining us tonight. To start things off, could you introduce yourself and tell our viewers a little bit more about your work and your long history studying the Perseids?
Yeah, thanks. Good evening, Alyssa. I guess I should say good morning at this point. So I've been studying meteors for the better part of, I guess, almost 30 years, and my interest is in all things related to these small particles coming into the atmosphere. I did my PhD working actually on the Perseid meteor shower, trying to figure out where that material came from. I'm now a professor in physics and astronomy here at Western University and have a team of researchers who study meteors from very small things to very big things. And we do lots and lots of work trying to understand where they come from, how many there are, and generally, could they be a risk to spacecraft? And that's sort of where our work with NASA dovetails.
Well, we are honored to have you on the stream. Not only are you incredibly respected for being a meteor scientist, but also a historian of sorts. Could you give us a little deep dive into the history of the Perseids?
Yeah, the Perseids have a really rich history. We've been watching and seeing the Perseids for more than 2,000 years. Records go back at least that far. The Perseids were among the very first meteor showers in the early 19th century that were recognized as being annual showers, so showers that occur every year at about the same time. And they also have the unique distinction of being the very first meteor shower that was ever directly linked to a comet. In this case, comet, of course, Swift-Tuttle, and that was done in the mid 19th century when people were first seeing the Perseids from a couple of different locations, figuring out their paths in the atmosphere and their orbits. And they just happened to be doing that at about the time the Comet Swift-Tuttle, was found in 1862 by two amateur astronomers in the U.S., Lewis Swift and Horace Tuttle. And so the Perseids have become kind of the granddaddy of all meteor showers, both because of its rich history going back a long ways and the time of the year it occurs. August, everybody's outside, everybody gets to see this very spectacular meteor shower, as long as it's, of course, dark and clear, which we have mixed amounts of that tonight.
Exactly. One of my favorite things about the Perseids is how long humans have been watching them, and to know that we are observing the same sky right now that they did thousands of years ago is insane. If you had to pick one historical Perseid moment that stands out, whether that's a particularly active year or a record-breaking observation, what would that be?
Yeah, so for me, I think the year I would pick would be 1993. There was a really big enhancement of Perseids in 1993, largely associated with the comet that returned the year before in 1992. Comet Swift-Tuttle returned in 1992. And that shower, I was fortunate enough to be in the south of France, got to see the shower for myself. It was amazing. There were thousands of people all over the countryside, and you could hear hoops and hollers as these bright meteors were lighting up the sky. And you could imagine it's just like what people would have seen 1,000 or 2,000 years ago when the comet came would come by in the same way. So really an amazing view, and it was an incredible year to see so many of these and get so much data, understand how the meteors relate better to the comet.
Wow, I love that. Now, for people who might have just hopped onto the stream and have no clue why we're watching this meteor shower, can you tell us what makes the Perseids so special and why they tend to be a favorite meteor shower for both scientists and casual skywatchers?
Yeah, so the Perseids are special on so many levels. So for everyday people going out and looking at the meteors, uh, they occur at a perfect time of the year, mid-August. Everybody's outside. It's often quite warm. The meteors, the geometry is such that you can see them really well in the northern hemisphere. So it's great for North America and Europe. They're also important for scientists because Swift Tuttle is one of the largest comets that goes close to the Earth. So it's a real chance for us to understand and see debris that's released from this comet and how it's evolved over time. And it's also important from a hazard perspective. There's a lot of these things hitting the upper atmosphere at very high speeds.
Mhm.
So if you don't have the atmosphere protecting you, you have to be a bit more concerned about that. And that's where sort of the satellite hazard angle comes in. So Perseids are special a whole bunch of different ways.
Awesome. Well, that leads me to another question I had. We mentioned earlier your work studying the Leonids, and of course, you've studied many other meteor showers too. Since tonight is all about the Perseids meteor shower, is there anything visually distinct about the Perseids compared to those other meteor showers?
Yeah, I mean, I think that the Perseids have a few distinctive characteristics. One is they tend to be pretty rich in bright meteors. We've been talking about that all
Mhm.
night. That's what the all sky cameras are all about. So some showers don't have lots of bright meteors, but the Perseids really do. The Perseids also move really fast, and one of the things that is often quite distinctive is they'll leave a trail behind. We actually call this a train, and it's just some glowing ionized gas that's
Mhm.
left in the path. And so the meteor sometimes can be visible for a few seconds in this sort of glowing embers that are left behind the Perseid. And that's also unusual, quite distinctive for the Perseids.
Awesome. Well, this has been fantastic, Peter. Thank you for sharing all this history and science with us. I know Bill has been dying to jump in and talk with you, so we're going to bring him back on. This is the lead of our Meteoroid Environment Office, Bill Cook. We're also going to bring back up our meteor camera so you two could do what you do best and watch the Perseids together, break down what we're seeing. So I'm going to step off for just a little bit and let you two take the reins. But chat, make sure you keep those questions coming for Bill and Peter, and we'll get to those here shortly.
Oh,
Take it
okay.
away, Bill.
Okay. Hey, Peter, you and I, we met back in the late 90s over the meteor shower hazard. And, you saw the 93 Perseids from France, and the 93 Perseids were the first shot across the bow as far as meteor shower forecasting, right? We had a shuttle
Yep.
mission delayed that year because no one was able to forecast meteor showers, which I think started you on your dissertation later on down the road, right? You had to get it done before the Leonid storms, right?
Yeah, that's exactly right. The Perseids in '93 were a big wake up call to all the things we don't know about meteors and trying to get a handle on the Perseids, which was half of the thesis work I did, and then the Leonids, which were coming up. The next few years during the late 1990s, that show really ramped up. And between the two of them, I think it's fair to say it almost redid the entire field. There was just so much interest, so much measurements, and concern. I think genuine concern about what these things might mean to space and space operations that kind of changed the field. So it's been really cool.
Yeah, and when you look at the effects of meteor shower on spacecraft in general, the risk is small compared to the ever-present sporadic background, right? We worry more about the
Yeah.
stuff that's always there than the Perseids or the Leonids or whatever. But the Perseids, I guess, they're the responsible for the most satellite anomalies and at least one case of potential satellite kill, right?
Absolutely, yeah, and as you point out, there aren't huge numbers of them, but they come in very fast. And I know we've always puzzled about this together for years. Why are the Perseids apparently such a hazard to spacecraft? And of course, perhaps their speed, something else going on, but it is a puzzle. But yeah, the Perseids. I don't want to say the Perseids are satellite killers because that's probably being a little overly dramatic, but they do seem to be associated with a lot of anomalies on satellites. And yeah, it remains a mystery.
Yeah. And tonight, you and I, unfortunately, I understand up in Western it's cloudy. We're cloudy here in
Yeah.
Huntsville. The clouds are breaking here, it looks like,
Mm.
looking at the camera feed. But if we want to look ahead to the future, you know, tonight's a normal Perseid shower, right? The activity levels we expect normal. What can we expect from the Perseid, say, over the next, say, 4 to 5 years? We have an outburst coming up, right?
Yeah, we do. Particularly 2028 looks like we're going to get close to some old trails that Swift Tuttle left behind. And particularly in 2028, it looks like that may produce a pretty strong outburst. And really, these outbursts are tempered by, how much material is close to the Earth from the most recent passage of the comet. And then there's also the tugs that Jupiter and Saturn make on the material. So there tend to be these sort of 11 and 30-year periods, and then 133-year period from the comet. And so 2028 is sort of the next time we're going to see one of these trails get really close to the Earth. And so that's going to be a really good Perseid year. Moon won't be quite as good as this year, but it still should be quite a show.
Yeah. So maybe the rates will double in 2028, do you think?
Yeah, I think that's a pretty reasonable thing. And certainly, 1993, I remember the rates were about triple normal. So double would be quite a show.
Yeah. So, um, going back to the Perseids there, in your observations of the Perseids, maybe 93 or recent years, is there a spectacular Perseid fireball you remember? Perhaps one with a very persistent train?
Yeah, so actually the most spectacular one I saw, maybe the most impactful one, was just as we were setting up in 1993 in the south of France for that really big meteor shower. There was a really bright, almost as bright as the full moon Perseid. And what was strange is we actually had set up some equipment to try to detect electromagnetic emission from from fireballs, and that one popped. It actually produced a pop in our equipment, and we've been studying that event for years. That was sort of the most strange fireball. We still don't quite understand exactly what was going on, but it was definitely one to remember.
Yeah. And the Perseids weren't always known as the Perseids. This shower had another name centuries ago. What was the story there?
Yeah, so there's a sort of a tale that the Perseids happened at a time when there's a Christian saint, Lawrence, and Saint Lawrence was put to death about the time of the peak of the Perseids, about 2,000 years ago. So the story is that, in the 19th century in particular, people began referring to the Perseids as the tears of St. Lawrence. And it really wasn't until the 19th century that we recognized the Perseids sort of in their modern form. And so, that far back, the Perseids were associated with other things, and the Feast of St. Lawrence was one of those associations.
Yeah, and we often joke and refer to this time of year, the Perseid peak, as Meteor Christmas. And
Yes,
and that's because Mother Nature gives us a present as far as the number of meteors, would you think?
absolutely. I mean, you pointed out, when you look at all the meteors we capture through the year, particularly the bright ones in the all sky cameras, often August 10th, 11th, 12th, I mean, that's 20 or 30% of all the bright meteors we see in a year. It's amazing. It really is like a gift from heaven.
Yeah, well, uh, we're not having much luck in the camera here, but I understand from the chat people in Ohio are having some luck with meteor sightings. So,
Yeah. I wanted to
congratulations.
cut in here, Bill and Peter, because I have been also keeping an eye on the chat. I've been noticing, yes, the Midwest is getting a lot of meteors, it seems. Since we have clouds, there's actually a chat question in the chat that pertains to that, and they want to know, are the meteors visible through the clouds?
It depends on how thick the clouds are, right, Peter? Uh, so, a really bright fireball, if the clouds are thin, you might see them. But in general, no, you can't see meteors through clouds.
Hmm.
Yeah, yeah, exactly. So sometimes the really bright fireballs will be like a light bulb flash, and you might see that just like lightning through clouds, but those are pretty rare. You don't typically see that.
Gotcha. Well, here's a good question for Peter. How do we know that the Perseids have been watched for 2,000 years?
Yeah, it's a great question. So people have gone back and looked at ancient uh, Chinese and Japanese and Middle Eastern records, and we've been looking basically in those records for accounts of stars falling from the sky at about the time you might expect them from the Perseids. Now, 2,000 years ago, the Perseids occurred in July, so you have to do a little bit of a time shift there. But we do find these fairly regular reports at the time you'd expect the Perseids. And we know the Perseids are an old shower, and we know Swift-Tuttle's a big comet. So it stands to reason there's probably been quite a lot of material reaching the Earth for that period of time, and that's how we make the association.
Awesome. All right, let me pick another one out here. I saw someone say we went from moon joy to meteor Christmas. Love that. That's a good one. Has the Swift-Tuttle comet ever been sampled before? What is known about it?
Well, Swift-Tuttle itself has not yet had a mission to it. There've only been a few comets that have had spacecraft missions that have sampled them. Vilt 2 had a sample return mission. I think, in fact, it's to date the only sample return mission from a comet.
Mhm.
But we do get to sample Swift-Tuttle every time the Perseids burn up in the atmosphere. We can actually break the light up into its constituent colors and get a spectrum, and we can tell what sort of elements are present. We see bright lines of emission from magnesium and sodium and calcium and iron, and it tells us something about what they're made of. So we do kind of get to sample it, but a little indirectly.
I love that. All right, I got one more question for you. And this one asks, how are the meteor peak times predicted or calculated? And can you also talk about the peak time for tonight?
Yeah, that's a great question. So that was the entire topic of my thesis, was trying to figure out those peak times. And as Bill will tell you, we had some luck and some years not so great luck trying to figure out exactly where these trails would land. So basically, we put the comet's past behavior into a computer, and we launch a bunch of particles, and then we see where they land relative to the Earth's orbit. And from that, we can kind of build up a sort of a synthetic computerized picture of, when these things hit.
Mhm.
Tonight we're expecting the peak, just about now. I mean, we're getting very close to the peak time, and that peak that we predict now is based on sort of long-term measurements of kind of where it historically peaks. There's always little peaks that appear during the Perseids, and sometimes these larger outbursts. But we're not expecting an outburst tonight, but never say never. The modelers can always be surprised.
Be optimistic, Peter. Come on. We're going to see tons
Abs-
of them.
Absolutely. Even without outbursts, the Perseids are extraordinarily rich. So we'll definitely see lots. Just whether we'll see an outburst, at a strange time, probably not this year. So probably tonight is the night for the peak.
Perfect. Awesome. Well, one of our team members from the MEO has been behind the scenes watching the Meteor camera and has grabbed some imagery for us that we can see now while we're answering some questions. So I want to pull those up now. Those are awesome. Bill and Peter, could you talk about these playbacks?
Yeah, these are from our cameras in Florida. The one you're seeing now is from the University of Central Florida campus, and
Amazing.
you're seeing Perseids captured by that camera again earlier tonight. So they're lucky in Florida; they're having better weather than we are, and these are meteors from earlier tonight.
Those look awesome.
Yep, some nice ones, and some aircraft, of
Yeah.
course.
I've started to learn how to spot the aircraft in there. This is great footage. I love seeing it. Well, these have been some incredible questions from the chat and playbacks from Danielle on our team, but we do want to let Peter enjoy these Perseids himself. Peter, thank you so much for joining us tonight. Getting to hear the science and the history behind these meteors while watching the Perseids live with you has been such a unique experience. We're grateful that you wanted to be a part of this.
It's been my pleasure. Well, I wish you clear skies and many more bright fireballs on the meteor cameras.
Absolutely.
Happy Meteor Christmas, Peter.
I love it.
Same to you, Bill. Same to you. Happy Meteor Christmas.
All right, if you're just joining us, welcome. We are watching the Perseids live on one of our meteor cameras right here at NASA's Marshall Space Flight Center in Huntsville, Alabama, with the lead of our Meteoroid Environment Office, Bill Cook. Let's get back to that meteor cam view and see if we could spot any. And of course, if you spot something before we do, shout it out in the chat. These shooting stars can come and go in an instant, so keep your eyes peeled. All right, Bill, can you give us a little refresher on what our viewers are going to be looking for on these meteor cameras? It looks like this one is our New Mexico State University camera, I believe.
Yes, and so there are clouds there. That's that white stuff all over the place, but there's some dark sky. And you'll look for, an object moving very quickly across the field of view, like we just saw in the UCF camera down in Florida. And they can appear anywhere in the sky, and they'll move quickly across the field of view. If you see something slow moving with flashing lights, that's an aircraft. So we're looking for something that's going to move really quickly across that sky.
Gotcha. Well, people see meteors randomly throughout the year, but meteor showers like tonight are different. For those of the viewers that are new to this, how do meteor showers differ from those random sporadic meteors you might see on any given night?
Well, meteor showers, all the meteors in a meteor shower come from a single object, like all the Perseids come from Comet Swift-Tuttle, or all the Geminids come from the asteroid 3200 Phaethon. But sporadics, they don't have a parent. They just are random bits of debris that are out there. So the difference that distinguishes a meteor shower from a sporadic is all the members of a meteor shower have the same parent body. They come from the same object.
Gotcha. Well, while we're watching, I actually have a question I have been wanting to ask you. We know that the Perseids are famous for being bright, but does that brightness change as the night goes on, or is it pretty consistent throughout the peak?
The brightness is a function of the speed, and all Perseids have the same speed, which is 132,000 miles per hour. So the brightness really boils down to how big the meteor is, not so much when it occurs. So you can get bright Perseids early in the evening, late in the evening, right before dawn. They can appear anytime. So the brightness doesn't have any consequence as far as the time of night. It can happen, bright Perseids can happen anytime.
Awesome. That makes sense. For our viewers who may be sky watching themselves, drop a message in the chat to tell us where you're watching from, whether you've seen any meteors tonight. We love seeing what you guys are saying. We've seen some luck in the Midwest. I saw someone from North Carolina saw some. Obviously, we had some playbacks of Florida, so love seeing it. Something I have always wondered is when a meteor streaks across the camera, how quickly can your team pull that data from that event, Bill?
If we know it happens, we can pull it almost instantaneously. Our cameras generally upload data every 30 minutes. So usually we know about meteors within a half an hour. But if we happen to be watching a camera feed and see it, we can pull that information immediately afterwards.
Awesome. I love that half the magic is in the real-time excitement and the other half is in the science that you guys do afterwards. Speaking of the work that your team does, we actually have a video prepared to show you guys an inside look into the automated Lunar and Meteor Observatory, or as we like to call it, the ALaMO, where Bill and his team observe these meteors from right here at NASA's Marshall Space Flight Center in Huntsville, Alabama. So let's watch that now.
For 20 years, a stargazing outpost at NASA's Marshall Space Flight Center in Huntsville, Alabama, has been quietly scanning the sky. This is the automated Lunar and Meteor Observatory, better known as the ALaMO. What began in 2006 as a new outpost for lunar impact monitoring has grown into one of NASA's most consistent sources of information about meteors, meteoroids, and the dynamic environment beyond Earth. The observatory saw its first light in March of 2006 and has spent 2 decades supporting NASA's Meteoroid Environment Office. These observations help researchers better understand the hazards spacecraft and astronauts may encounter beyond Earth's atmosphere. The ALaMO includes 2 domes, a 15-meter observation tower with roll-off roof, and an operations center. Every part of this facility is built for precision. Automated systems that scan the moon for tiny flashes, sensitive cameras that capture meteors streaking through Earth's atmosphere, and an operations center where experts can review each burst of light. In the last 2 decades, the observatory has recorded hundreds of lunar impacts, including flashes bright enough to reveal newly formed craters. Each detection helps scientists better understand the risks spacecraft and future astronauts may face as they venture beyond low Earth orbit. The ALaMO facility also helped launch networks of all-sky cameras that track fireballs across the United States, and more recently joined a global network of instruments collecting meteor data around the world. These observations allow researchers to map meteoroid paths, identify their origins, and refine models that protect NASA missions. Day after day, night after night, this observatory has built a record of impact flashes, fireballs, and celestial events, data that helps safeguard our human explorers and our spacecraft, support scientific discovery, and deepens our understanding of our solar system.
That was an amazing behind-the-scenes look at our observatory. Now, a lot of people don't realize that with the right equipment, we can actually hear those meteors too. And I saw someone in the chat asking about this. This is a phenomenon called meteor scattering, and it creates a sound we call a meteor ping or echo that we can hear with radio equipment. Bill, can you tell us how this works?
Sure. When a meteor burns up in the atmosphere, it leaves that streak of light we call a shooting star or meteor, but it also leaves a trail of ionized matter behind it, an ionization trail. And if you have a ham radio tuned to frequencies in the tens of megahertz, any distant signal, like from a distant radio station or TV station that bounces off that meteor trail, will be picked up by your receiver, and you'll hear a ping like sonar. So, you need to have a distant transmitter, a radio or TV station that's over the horizon. But if you have a receiver tuned to, say, like 1725 megahertz, somewhere in that range, you can hear meteors. And the beautiful thing about that is you can hear them in the daytime as well as at night. So you can hear them all the time. And believe me, you hear lots of Perseids pings on these little systems, which we call forward scatter radars.
Awesome. And I think we actually have an example of what those pings sound like.
Yep, I hear it.
Yeah. They sound kind of eerie.
Yeah, you hear
like a whistle.
It's just like a submarine, sonar from a destroyer looking for a submarine. But a lot of amateurs will actually count meteors and provide data to scientists, and this helps us establish the intensity of the shower because you can count meteors in the daytime with this setup.
Very cool. If somebody wanted to listen to these meteor pings at home, how would they do that?
Well, you would need a receiver. A lot of people use ham radios. They're these programmable radios. And an antenna, and you would basically tune to the frequency of a distant radio or TV station, and you want the carrier from that, which is the constant signal they send out. And if you do that, you'll hear meteor pings.
Does the length of that echo correspond with the size of the meteor?
Pretty much. It corresponds to the length of the ionization trail, and that the longer the ionization trail, the longer the ping. And the amazing thing is a meteoroid only a millimeter across. Imagine a millimeter on a ruler. That meteoroid will leave an ionization trail the length of a battleship.
Wow.
Makes it very easy to pick up with a simple forward scatter setup.
Well, I want to grab one or two more questions from the chat while we're continuing to look at this meteor cam from New Mexico State University that we're watching. Here is a good one from Layla1376B5U. Hope I got that right. What is something about the Perseids that scientists still don't fully understand?
It's a good question. What is something about the Perseids scientists really don't understand? Well, from my perspective, I'd like to be able to predict Perseid outbursts better. Peter mentioned that occasionally we miss the forecast, and the Perseids every now and then can surprise us. For example, the Perseids have been recently showing two peaks. You know, we think of a meteor shower having one peak, but if you look at the shower data, we see two peaks close together. And that second peak is a relatively recent occurrence, and we're still trying to figure out what causes that second peak. We think they might be really old Perseids, but we're still looking into it.
Gotcha. All right. We have another question asked by Jessica that says, why does the brightness change as it moves across the sky, going from dull to bright to dull/invisible again?
Well, and what you're seeing is the meteor, it's coming in, it's burning up, and it also is breaking apart. So you may see the meteor as it burns up, it gets brighter, then it breaks up, it'll get dimmer, and then as those pieces burn up, you'll see it get brighter again.
Gotcha. All right, here's another one I want to ask you. What type of minerals or metals are in the meteors? Is that why they are so flammable?
Uh, well, they're not really flammable. There's standard elements in meteors, carbon, sodium, you know. We think of these things as fluffy bits of rock and ice held together by organic glues. So they're normal elements, but they're not flammable. What causes them to ablate or burn up is they're entering the atmosphere with such speed, the atmospheric friction, to borrow a simple term that is often thought of as incorrect, but when they enter the atmosphere, they generate so much heat, they simply vaporize.
Gotcha. Well, I am loving all of these questions, and I have seen some asking about the International Space Station. So I know that astronauts aboard the International Space Station occasionally report seeing meteors, and we have tons of images taken by our astronauts of the ones that they have been lucky enough to capture. We're going to bring one of those images up now. That is one of my personal favorites from the Perseids Meteor Shower in 2011, captured by NASA astronaut Ron Guerin. I absolutely love this one. I think you've seen this one before, Bill.
Oh, I love ISS because there are no clouds.
Yes.
You know, that's great. And the other thing is, on Earth, we have to look up to see meteors. The ISS astronauts look down. It's a totally different perspective.
Absolutely. And we have a lot of connections to the International Space Station here at NASA's Marshall Space Flight Center. We have a team called the Payload Operations Integration Center, is where they work here at Marshall. And they do the science on board the International Space Station. They help monitor that science that goes on there. They're basically our mission control for the science conducted on the orbiting lab. They work around the clock to make sure experiments aboard the space station run smoothly. And they help astronauts gather images like this, which is absolutely amazing. The space station is orbiting 250 miles above Earth, which gives them this stunning perspective. So I know one of the questions we've been asked a lot is, are the astronauts on board the International Space Station in danger of any meteors? Could you talk a little bit about that, Bill?
Sure. So ISS, you know, again, it's outside the atmosphere, so there's no ablation. The meteoroids can strike ISS directly. And meteoroids do strike ISS, as well as little pieces of orbital debris. However, ISS has armor, you know, because it carries humans and they got to live there for months upon months. We have armored ISS. It is the tank of low Earth orbit, and it has shields to protect it.
And I think we have some of those shields here.
Yes, we do. We have a prototype. If you look on the left on the screen there, you'll see ISS prototype armor. So on the very left there, yes, there's the armor. So at the far left, you have a plate, an aluminum plate at the very far left, and that is the bumper shield that breaks the meteoroid or piece of orbital debris up. So the meteoroid or piece of orbital debris will strike that plate, and it'll be broken up into like a shotgun blast. And then in between those plates, you have Nextel Kevlar, like in bulletproof vest, that will stop that shotgun blast or most of it. And then the back plate, that's the pressure wall. That's beyond, that's where the astronauts live. So you don't want any holes in that back plate. And this one, when we tested it, the Nextel Kevlar in the front plate broke the test projectile up, but it still was powerful enough to get through the Nextel Kevlar and put that bump on the back. It dinged the back plate. So, you know, this is prototype station armor. It was, you know, this was one of the first gun test articles, and the actual station armor is even better than this. Station armor can stop a 1-inch meteoroid moving at like 70,000 miles per hour. So again, space station is the tank of low Earth orbit. So we don't worry about the astronauts much during meteor showers because of that. We have this wonderful armor on space station.
Awesome. And those meteorites that we have right there, are those about the size of what could be making those holes?
Yes, maybe a little bit smaller, but yes, those meteorites are about the right size to make the holes. Now, what you have on the right is just a single metal plate, and it's why we don't use monolithic plates to protect against meteoroids, because there's no bumper shield, there's no Nextel Kevlar, and the meteoroid or the piece of orbital debris just blasts big holes in it when it hits. So metal plates, not so good for shielding.
Thank you for explaining that, Bill. That makes a lot of sense. I'm glad to know that our astronauts are safe when they're in spacecraft and aboard the International Space Station. For right now, let's get back to focusing on that sky. We're going to look back at our meteor camera and see if we can start picking up something. See if those clouds are starting to move. We're getting closer to that peak. I believe that's a plane we're seeing there.
Yes, the sky is getting clearer. Well, that's good. I don't see any lightning anymore. That's great.
Awesome. Well, I'd love to make this full screen so that you guys can really focus on the sky. Please let us know if you spot anything. Put it in the chat. We don't want to miss a single meteor. We're going to leave this full screen for a little bit, and we'll be back with you in just a second. That was some great sky watching from all of you. I was keeping an eye on the chat to see what you guys were spotting, and I'm seeing a lot of great questions in there as well. One that always pops up during meteor showers is some version of, should we be worried about these meteors hitting Earth? And that is a totally understandable question, especially when you see those bright fireballs streaking across the sky. The short answer is no, but our next guest is a perfect person to talk about this more. I'm excited to introduce someone who knows a lot about what NASA does to monitor and protect our planet from hazardous objects. Joining us virtually from California is Amy Meinzer, lead for NASA's NEO Surveyor mission. NASA's Near Earth Objects Surveyor mission, or NEO Surveyor, is designed to discover and characterize most of the potentially hazardous near Earth objects. Amy is an Earth, planetary, and space sciences professor at UCLA, and she is the lead for the mission. Amy, thank you so much for joining us tonight. Before we dive into the Perseids more, could you tell our viewers a little bit about your role and what your planetary defense work with NASA looks like?
Sure. I'm super lucky to get to do this work. Thank you so much for having me here. So we are busy building what will hopefully be NASA's sort of biggest, best observatory for looking at what is the contents of our solar system, looking for the things that can get close to the Earth, both asteroids and comets, and trying to characterize the numbers, sizes, and orbital element distributions of these objects so that we can predict if there's going to be a potentially hazardous object that could get close to us in the future. That's the goal.
Awesome. Well, a lot of people hear the phrase planetary defense and they think it's something out of like a sci-fi movie, for instance. What does planetary defense really look like day to day?
Sure. It's a really practical question. Is there anything out there in our solar system that could get somewhat close to the Earth or even really close to the Earth?
Mhm.
And if so, what should we do about it? That's planetary defense to me.
Absolutely. And I know NASA has had a lot of success with our DART mission, for instance. We're also looking at going to objects like Psyche, the asteroid Psyche. So I know NASA's doing a lot of work on that, and I can't wait for NEO Surveyor. What is one misconception about planetary defense or asteroid tracking that you wish more people understood?
Yeah, okay. So I love sci-fi. I'm a huge sci-fi fan. I mean, like a lot of us, right?
Absolutely.
But the movie, do you remember Empire Strikes Back from Star Wars?
Yes.
There's There's that scene where the Millennium Falcon is cruising through the asteroids, and there's asteroids everywhere, and they're just floating around, and they look like they're about to hit them. That turns out to not be quite like what our asteroid belt is actually like. Our
Ah,
asteroid belt is a bit different.
yeah.
So it turns out if we were in the middle of our asteroid belt here in our solar system, most of the asteroids would look like tiny, small, unresolved dots.
Oh,
So
interesting.
there's still a lot of them. It turns
Hmm.
out there are millions and millions of these objects, but they're so spread out and space is so big that each individual object would just look like a point of light. If you were standing on the surface of one, even if you were in the middle of it, it would still mostly look like dots. It
Wow.
wouldn't look like the Empire Strikes Back with big giant rocks floating all over the place.
That is so fascinating. Well, I want to take a step back and talk about the NEO Surveyor mission a little bit more. What is the latest update on that mission?
Yeah, so we are deep in the middle of building the project right now. So what we're trying to do is we're trying to build a space telescope that will be very sensitive to the asteroids and comets that can get closest to the Earth. In other words, we want to look for the things that really do have the potential to get close. And if they are going to get close, we want to be able to spot them when they're far away from the Earth,
Hmm.
really far away, so that we can predict where they will go. And if there's any chance of a close impact, we want to be able to pick it up and spot it and say, okay, we want to actually spend special attention on these particular objects so that we can really follow their orbits, if that makes sense.
It does, absolutely. The mission sounds so exciting, and I cannot wait to see it in action. But I don't want to steal any more questions from our viewers. So if you do have questions for Amy, make sure to drop those in the chat. We'll ask her here shortly. In the meantime, I would like to bring Bill back in. Bill's team is the one who studies those tiny particles burning up in our atmosphere, and Amy works with the teams tracking the much larger objects further out in space. So between the two of them, we've basically got the whole solar system covered tonight. I'm going to let Bill and Amy take over for a bit while we keep watching our meteor camera. We're going to cut between the Huntsville, Alabama camera and that New Mexico State camera. So Bill and Amy, I'd love to hear from the two of you about how your worlds overlap, how meteors, meteor showers, near Earth objects all fit into NASA's bigger effort to understand and monitor our cosmic neighborhood. So, Bill, take it away.
Yeah, so Amy, you study asteroids, or what I like to call the rocks of doom. I study the flotsam and jetsam of the solar system, the small stuff. But um, we tend to put things in categories as humans. Like, as I mentioned earlier in the broadcast, a meteoroid is something smaller than a meteor. An asteroid is something larger than a meter in diameter. But Mother Nature is not into our categories so much. So we have a smooth continuum between asteroid and comet. So often when I deal with asteroid people, I have to be mindful of that transition. So, what are your thoughts on our classifications? Are we making it too simplistic in a lot of ways?
I think that's really wise words. I mean, nature makes these little bits of leftovers from when our solar system first formed, and some of them are as big as mountains, others as small as tiny, tiny dust grains, or even, maybe a rice grain if it's really a bright meteor, right? I mean, so nature doesn't really care about how we as humans label all of the things that she makes. And if you happen to be a bit of a larger piece, maybe we'd call you an asteroid. But if you're a really tiny piece, we might call you a meteor. And if you happen to land in the Earth's atmosphere and then make it all the way to the ground, we'd call you a meteorite. But it's the same thing at its core, right? I mean, these are fundamentally the same objects. It's just how do we as humans classify them based on the phenomena of what has happened to them as they encounter the Earth. How do you feel about that?
I think that's very true. What interests me, I guess, is that even when it comes between asteroids and comets, we think of asteroids and comets being fairly distinct, but we have things called active asteroids that look comet like, and we have dead comets that look asteroid like. So it can get really confusing trying to figure out what's what and putting it in our nice, neat little boxes.
I feel that so much. I feel like that's the essence of it. Probably a while ago, we used to think, okay, there were these objects called asteroids that occupy certain orbits, and then these completely separate objects that are comets, and ne'er the two shall encounter, ne'er the two between. But it turns out now, I think it's safe to say there is a spectrum between comets and asteroids, where asteroids would be things that are more rocky or metallic dominated, and the comets being things that have more volatiles, to use the term, ices, basically, kind of the dirty snowballs of the solar system. But there's everything in between. We've got things that are called active asteroids, as you mentioned, that look like they are normal asteroids from their orbital perspective, and yet they sprout tails like a comet. So that's really strange. And on the flip side, you have things that look completely asteroidal, meaning no sign whatsoever of cometary activity, but they have orbits that look like comets. So I feel like to me, that means the solar system is a much more complicated place with a more kind of a graduated continuum of objects that range from the rocky asteroidal material to the more volatile rich stuff that we would call comets. And there's sort of everything in between. I don't know. How do you feel? What do you think about that?
Yeah, Mother Nature is just not very respectful of our categories. It would be nice if she was, but she's not. So it can get a bit confusing, certainly. Um, you are, leading Neo Surveyor, and Neo Surveyor is in part, arose in part because NASA has a requirement from Congress, right, to save us from rocks of doom. So, what is Neo Surveyor going to help us with as far as our congressional mandate for NASA? What is it designed to look for?
Yeah, I mean, so when I started this particular project, I thought, well, we know where all the asteroids are in the solar system. Surely we know because, it's we're so advanced in technology, we can see galaxies at the furthest edge of the solar system, so surely we know where all the asteroids are. But it turns out that's not quite true. We know where a lot of the very largest asteroids are, and we know where Some of the smaller asteroids are, but we actually don't know where the majority of them are. And that turns out to be a mandate from Congress because I think at some point Congress recognized that it's in the public interest for us to just know what's out there. So, the objective of this project is to fill out our understanding of the asteroids that are large enough to cause what I would call severe regional damage to the Earth, and make sure that we know where they are, what their orbits are like, can we track them into the future, and basically have secured them so that we know where these objects are likely to go and if they have any particular chance of having a close encounter with the Earth. That's the primary objective of the project.
And how big an asteroid can cause reasonable regional damage on the Earth? Because, we had Chelyabinsk back in 2013. It was a 20-meter diameter asteroid, and it created a 500 kiloton explosion right above Chelyabinsk, Russia. So, how big an asteroid causes regional, I keep wanting to say reasonable, but regional damage?
Yeah, I mean, of course, it's a little bit of an estimate, admittedly, but we know from the Chelyabinsk object that at 20 meters, this is an object that broke a lot of windows, but that was kind of all that happened. So we know from Meteor Crater in Arizona, which we think was created by something that was about 50 meters across, that now you produce a crater and a fairly large one. We know that's sort of the lower bound of what we really need to worry about. I would say, based on a lot of studies that have been done, about 100 plus meters, 100 to 200 meters is sort of the range where it's not a good day if that happens. We would really like to know where the majority of those objects are, and we want to be sure that they have no chance of impacting the Earth in the next century.
And if I recall correctly, those studies basically showed that uh, if a 100-meter asteroid enters the atmosphere, it would still be broken up by the atmosphere, provided it was stony. So you would only have pieces hitting the ground. It would not survive to the ground intact. Is that correct?
Yeah, so basically we know from Chelyabinsk that that object at 20 meters was largely reduced to rubble. In other words, tiny pieces. The largest fragment was, I want to say, about the size of if I put my arms in a circle. That's about the biggest fragment that made it from the 20-meter Chelyabinsk object. That was recovered by divers who went into a lake and were able to pull up the largest piece. So we know that's about the biggest piece that would survive if something is 20 meters across. If it's about 100 meters or say 200 meters across, we know that a lot of it could make it to the ground intact. And that's something that we just don't want to happen. In other words, we want that to we want to have the opportunity to push such an object aside so that it does not impact the Earth. That's the objective.
And uh, when you think about all the asteroids you know of, is there any one of them that keeps you awake at night that you would like to know more about?
Mm. Honestly, I have to say it's the ones I don't know about today.
Hmm.
Those are the ones that keep me up. In other words, the current program has done a very good job of tracking about, I would say, 40-ish% of the near Earth asteroids, not near Earth objects, but near Earth asteroids that are larger than the sort of 140-meter threshold or sort of big enough to cause a lot of ground damage. We know of about 40% of those roughly today, but we don't know of the roughly 60-ish% or so that remain to be found. So those are the ones that I worry about because those are the ones we want to find so that we can kind of say for sure whether they have any chance of impacting the Earth or not.
And Neo Surveyor will provide a unique perspective because it will give us, it will be better able to survey the sky than ground based instruments. We know, for example, Chelyabinsk, the Chelyabinsk asteroid came at us out of the sun. How close can Neo Surveyor observe to the sun? Because that's kind of our blind spot, isn't it?
Yeah, that's a difficulty with telescopes on the ground. All of us on the ground who are observing have one big fundamental thing, which is the sun. In other words, the sky is bright during the day. This makes it challenging, although not completely impossible, but challenging to use astronomical telescopes to look at the sky during the daytime, or even at twilight or at dawn. The sky is just very bright because we have an atmosphere on Earth. So the idea with Neo Surveyor is to get away from the Earth get off of the Earth to be in space, so there's no atmosphere to basically have to contend with, we intend to be able to rotate the telescope to look as close to about 45 degrees from the sun. So we want to observe that sort of near sun's part of the sky so that we have a better chance of observing asteroids that are in more Earth-like orbits, if that makes sense.
Yes, it does. And also maybe to catch an Otten class asteroid coming at us out of the sun too on occasion.
Yeah. Yeah. So for our friends out there, Ottens are basically things in the most very Earth-like orbits, meaning very circular orbits, things that are kind of close in terms of the Earth has a very circular orbit, I would say, and these are asteroids that have orbits that are very similar to the Earth's, which means that they have a large chance of encountering the Earth because they get close. So these are the objects we particularly want to pay attention to, and we would like to understand how many there are and what their trajectories look like.
Yeah. And when you say get away from the Earth, Neo Surveyor, what sort of orbit will it be in? Will it be going out to the Lagrange points or will it be hanging out in low Earth orbit? Where will it go?
Yeah, we want to get just away from the Earth, but not too far. And there's a couple of reasons for that. We want to be in the L1 Earth Sun Lagrange point, which is just inside the orbit of the moon. So we go toward the sun's direction, but not that far. We'll be a few times the distance of the Earth to the moon away, but we'll just sort of hang out there. And there's a couple of reasons for that. One, we do want to get away from the Earth because we are going to be using a telescope that senses the heat emitted by the asteroids. So we won't be looking for the light that is reflected off of them, but instead we will be looking for the very faint heat that they give off because they are warmed up by the sun. Because of this, we do want to be away a little bit from the Earth because the Earth itself is warm. So we want to be outside the kind of regime where the warmth of the Earth dominates our seeing. So we want to get into the cold dark of space. And it turns out a few times the lunar distance from the Earth is a good place because it's a little bit further away. It's a cooler environment. Yet at the same time, this particular orbit, this L1 Lagrange point, is nice because we maintain a kind of a constant distance back to the Earth that's relatively close, which means we can get all of our images back. In other words, we have high-speed internet, essentially. That's important.
Okay.
All right, Bill, I'm going to cut in here because I have seen a lot of good questions in the chat that I want to ask you guys. Before I get to that, though, I wanted to mention that a lot of folks are saying that they're seeing clouds, but we do have some people in Ohio, Michigan, and Texas I've seen that are seeing some meteors tonight, so that's really exciting. We were just looking at our camera here in Huntsville, Alabama. Our clouds are gone for the most part, so that's awesome. I'm hoping we'll get back to that soon so that we could spot some Perseids. But before we do, I want to get into some questions real quick. This one's a good one, I think, for Amy to answer, and also Bill. But what size is needed for a meteorite to remain in the atmosphere long enough to eventually crash to Earth? That's from Ethan Leroy 948.
Boy, that's a great question. I mean, Bill, you'll answer this too, I expect, but Chelyabinsk taught us a lot, I would say, in the sense that we know that object was about 20 meters across, so, a house sized roughly. And that did make it to the ground, but mostly in pieces. And again, the largest sized fragment that came from that object was about maybe, if you put your arms in a circle, something like that. So we know something that's 20 meters across is going to be mostly broken up by the atmosphere, though not completely. Bill, your thoughts about that?
Yeah. So a lot of the meteorite droppers, and we've observed a few this year, especially back in March. It seemed like the sky was falling back in March of this year. They tend to be only between 1 and 5 meters in diameter, so smaller than Chelyabinsk. But they don't produce a lot of meteorites on the ground, right? Chelyabinsk was, like you say, 20 meters across. There was a big meteorite field, a strewn field, and there were lots of meteorites. The smaller rocks, they drop meteorites, but there are not many of them. And so, you can get meteorites from 1 meter size asteroids, but you're not going to get a lot on the ground. It makes it challenging to find them.
Hmm. Awesome. Well, I have another question here. The Perseids have come from Comet Swift-Tuttle. So Haley is asking, where is this comet from? Did it break off of something?
Mhm. Mm. Boy, that's a great one. What do you think, Bill?
Well,
Did it come from something else?
well, Swift-Tuttle, it's got a big orbit. Maybe it was a long period comet, maybe even a Kuiper belt object before it got perturbed into its current orbit, right? It takes 133 years to go around the sun. I do know it's a NEO, a near-Earth object, so, it kind of is something we keep an eye on. It's not going to hit Earth for many centuries, if not millennia. But, it may have been in the Kuiper belt. It may have even been an Oort cloud comet before it was perturbed into an existing orbit. I can tell you,
Yeah,
though, that Jupiter messes with its orbit a fair amount. So,
that's for sure. And it's a large comet, it's 26 kilometers across, which is a very large object. In fact, I believe this would be quite a bit bigger than the thing that made the dinosaurs extinct, the
yeah,
Chicxulub object.
yeah,
This is a big comet. This thing is large. It leaves a big mess as it goes through the solar system, so that's why we have this beautiful meteor shower. But we're pretty glad that it has not made any more mess than what we see, so to speak.
yeah.
It's a big
Thank
one.
goodness it isn't going to hit us, so we can
Yeah.
enjoy the pieces without the parent coming in at us.
Yeah, just send us those
Yeah.
pretty fireballs.
Exactly. Well, it is interesting how something comes from the Oort cloud into the inner parts of the solar system. In other words, this object has a 133-year orbital period, which is a kind of of an interesting intermediate length between the Oort cloud objects, which have, hundreds of millions to billions of years orbital periods, to things that are like our asteroids that orbit, every few years. So this is an object, I would say, in transition. Well, on an astronomical timescale, which could mean millions of years. What do you think, Bill?
Yeah, it's a nice transition object. Um, I was around in '93 when it showed up in the inner solar system. It's one of those things you may get a chance to see it once in a human lifetime, of course, but it's nothing like, say Comet Hale-Bopp, where it was seen back when the cavemen were on the Earth, right? It comes around and
Yeah.
often enough to remind us it's here.
Yeah, I guess what its next approach, very close approach to Earth is due 2130 or something like that, I think.
Yeah, around
So
2123, but yeah, somewhere in that vicinity. Again, Jupiter changes the orbital period, so it's you got to pay attention to the dynamics there.
Well, I have
yeah.
another question. This is also from Haley, but I have to ask it. It's so good. Do scientists ever wish on shooting stars?
Oh, absolutely. All the time.
I love that. Bill, what about you?
Only on Meteor Christmas.
Meteor Christmas. Yeah. Amy, we were talking to Peter earlier, and we said Moonjoy is the new Moonjoy is now Meteor Christmas.
I love it. I
Yeah.
love it.
Well,
Got to have some traditions.
absolutely. One of our team members from the MEO has been behind the scenes watching the meteor cameras that we have across our All Sky network. We've obviously been looking at live views from Huntsville, Alabama camera, but we have grabbed some imagery from some of our other cameras. I want to pull a few of those up now so we can show you guys.
Oh, there you
Yeah,
go.
these
These are quick.
these are Perseids, and they're from that's from the camera in Tennessee, Tullahoma, and that's from a camera in North Carolina, and this is from a camera in North Georgia. These are all meteors tonight, and by their speeds, they're all Perseids.
Mm. And Danielle, who's
Fantastic.
behind the scenes, said the one in Tullahoma is confirmed to be a Perseid.
Mhm.
Mm-hmm.
We caught that in multiple cameras, so she's already got a trajectory and a speed on it.
Awesome. Chat
Bill,
is
how big do you reckon these are? Would you say?
These are about magnitude -1, -2, so they're probably a few millimeters in diameter.
Wow. It's
Yeah.
quite amazing if you think about it. Something a few millimeters in diameter
Yeah, but
can
it's
make
plowed
that
into the
light.
atmosphere at 132,000 miles an hour.
Well, the chat is sending a lot
I
of
love it.
hearts. If you guys are excited for Meteor Christmas, you should drop like a Christmas tree emoji in the chat. Let us know. This is what Meteor Christmas is all about. I'm loving it, loving the excitement. Everybody's sending hearts.
So, Amy, while we're watching this, I got a question. You're building Neo Surveyor. I'm assuming you build in the usual safeguards to protect it from these little bits of flotsam and jetsam.
Oh, you know it. So we actually call it MMOD, and this basically, of course, is NASA speak for we have to worry about, getting hit by the thing we're sort of looking for, which is meteors. So we do have to actually worry about meteoroid protection because even in the deep space environment, so in other words, just outside the orbit of the Earth, but basically just beyond the lunar environment, beyond the orbit of the moon, we do still have to worry about little bits of debris. So for that, we actually analyze the environment. We predict how often we think impacts from small debris objects could occur, and then we try to deliberately harden parts of the spacecraft to act as shields, essentially, so that we don't get punctured by a small piece of flotsam and jetsam here from the solar system. We do have to be careful.
Yes. Well, Bill, while we have you and Amy still here, can you talk a little bit more about the rate per hour that we're going to be seeing as we get closer to the peak tonight here in Huntsville?
Yeah, here in Huntsville, if it's clear at 4 a.m., you should see at most 20 meteors per hour, given the sky brightness here. And Amy, you're in Los Angeles.
Yes, that's right.
So if Amy went outside her door and did some meteor watching, she might see 2 Perseids per hour because the sky is that bright in Los Angeles. Location is everything when you observe a meteor shower.
Absolutely.
That's for sure.
What about in those really nice areas, those dark sky areas? What could people expect to see there?
Yeah, I think there's one up in Virginia, and I just ran a calculation, and those people should maybe at 4 a.m. see about 50 Perseids per hour, almost
Wow,
one a minute.
that's amazing.
Wow.
Yeah, Amy, you need to find a dark sky.
I'm telling you, Los Angeles is not the best place.
Well, I don't want to keep our guest up too long. Amy, thank you so much for staying up late with us tonight and for walking us through how NASA finds and tracks asteroids and comets. Your insights into NASA's upcoming planetary defense flight missions were incredibly helpful and, judging by the chat, definitely appreciated.
Oh, you're most welcome. And Bill, happy meteoroid hunting.
Yeah, well, thank you, and good luck with Neo Surveyor. I'm looking forward to seeing the launch.
Thank you. We will get there. It'll be good.
Awesome. Thanks, Amy. Now that we've talked about how NASA tracks objects that could impact Earth, let's shift gears and talk about how NASA tracks space rocks that impact the moon. Because the moon doesn't have an atmosphere like Earth, its surface gets hit by meteoroids all the time. Those little impacts can actually tell us a lot about the space environment around both Earth and the moon. Bill, we've been watching meteors zip across our camera feed throughout this all-sky camera tonight, but you and your team also keep an eye on meteor impacts happening on the lunar surface. Can you walk us through how the MEO studies those flashes on the moon and what we learn from them?
Sure. So on Earth, when a meteoroid enters the atmosphere, it creates a streak of light we call a meteor, and we study the meteor to determine the characteristics of the meteoroid, how big it is, how fast it moves. But the moon has no atmosphere. So the meteoroid strikes the surface, and then when it does, it leaves a flash of light. And in this video, you will see flashes of light, and it repeats twice for each flash. And those flashes, like that really bright one there, are caused by meteoroids striking the moon's surface. And we can see these with small telescopes, or big telescopes if you got one, here at Earth. So at our observatory, we point these telescopes at the moon, and they have low light level video cameras, and they record these flashes. And from the brightness of the flash, we can tell how big that meteoroid is when it hits the moon. And of course, we use that information to help inform our moon programs like Artemis and Moonbase, so they can design their hardware, whether it be a lunar rover or a lunar habitat module, because you don't want one of these going through your habitat module if you're staying there on the moon. So we monitor the moon with these telescopes and study these flashes to help us design the stuff we're going to place on the surface of the moon.
Absolutely. And we have been talking about moonjoy tonight. The term moonjoy actually came from the moment that the Artemis 2 crew spotted a lunar impact in real time as they were going around the moon for the mission. And the science team on the ground was in absolute joy from hearing this. So that is an awesome thing that we get to play a part of with these lunar impacts. Now, Bill, Perseids can hit the moon too, right?
Yes, but unfortunately, generally when the Perseid shower occurs, the Earth-Moon geometry, to borrow the expression, sucks. So we have a database of like 450 lunar impacts we've observed, and only 2 of them are Perseids. We have a ton of Geminids, but every time we try to look at the moon during the Perseid shower, the geometry's not right, and we end up not seeing many.
Ah, gotcha. Well, it's interesting that this research that you guys do, this data that you gather, is going to help for our moon missions, but it does also give us a better idea of what's happening around Earth, right?
Yes. Yes, because the stuff that's hitting the moon is also burning up in our atmosphere. And most people think that the moon, it's 400,000 kilometers away. To them, that's a big distance. But in terms of solar system distances, that's nothing. So the Earth and the moon encounter the same meteoroid environment. What affects the moon affects the Earth, and vice versa.
Awesome. Well, it is amazing that your team is studying to help NASA with future mission planning as we prepare to send astronauts back to the lunar surface. Those split-second impact flashes may be small, but the information that they give us is huge and will actually help keep our crews and hardware safe during the Artemis missions. Now, speaking of our astronauts, let's see. Yeah, it looks like we actually have something special in store for you guys. We're going to pull up a camera from the International Space Station for a look at what the shower could possibly look like from above. We're super excited to have this view thanks to our Payload Operations Integration Center here at NASA's Marshall Space Flight Center. And for those of you in the chat, yes, this is a real live view from the International Space Station right now. We're going to hope that we could spot some meteors entering Earth's atmosphere from this view. The space station is orbiting about 250 miles above Earth, which gives us this stunning perspective that you just can't get from the ground. Now, we talked about this earlier, Bill, but can you tell us again how the astronauts on board the space station are protected from these meteors while we're looking at this stunning view?
Yes, well, as I said earlier, the space station has special armor, bumper shields, that protect it from meteoroids. And these bumper shields have an outside plate to break the meteoroid up, and underneath that are layers of Kevlar Nextel, like in bulletproof vests, to protect it. So space station is very well protected against meteoroids. It's the tank of low Earth orbit, and the astronauts on board space station are perfectly safe during meteor showers and have the pleasure of looking down into Earth's atmosphere to see meteors where we look up.
That's awesome. So where should we be looking at during this view?
You want to look along the limb of the Earth and see if you can see a streak. So right where the Earth's limb meets space, in that little hazy area there, that's the atmosphere, and you want to try to see if you see a meteor burning up in that little thin layer there.
Awesome. while we enjoy this stunning view, I have to give another shout out to our Payload Operations Integration Center at Marshall for getting us connected to this camera feed for the night. This is really awesome that they did this. That team works 24/7, 365 days a year supporting the science that is done on board the orbiting laboratory. And tonight they are the ones helping us try and catch meteors from this view. So big thank you to their team and of course the team at NASA's Johnson Space Center's Mission Control as well. Let's just take a few minutes to enjoy this view one last time. We're going to make this full screen. We're going to keep it full screen, but let us know if you spot any meteors in the chat. From this angle, they could be a little bit more faint, and go by even faster, so make sure you keep your eyes peeled for it. Bill and I will be back here shortly to talk about what we saw. Awesome. We had a short little view from the ISS before it went into a loss of signal, which is when it orbits around the Earth and we lose communication with it, which is totally normal. But what a great view that was for a split second that we got it. Thank you again to our team here at NASA's Marshall Space Flight Center that helped us get that view. Speaking of right here at NASA's Marshall Space Flight Center, we have been watching our meteor camera here in Huntsville, Alabama at our observatory for a little bit. And I am excited to announce that we got a really good meteor that we're showing now from our meteor camera.
Oh, that's a
That
beautiful.
is a nice one.
Yeah, that's a beautiful Perseid.
Oh, wow. Would that be considered a fireball, Bill?
Yes, that is right enough to be a fireball. On the low end of a fireball, but it's a fireball.
That is amazing. Do we know about what time we got that one? I don't know.
Yeah, it's down there at the bottom. So that occurred at 12:49 a.m. Huntsville time.
Absolutely, just a few minutes ago. Huh?
Yeah, so about 12 minutes ago.
Wow, that's amazing. Oh, that's a beautiful one. If you are just joining us, we are watching for Perseids on our meteor camera in Huntsville, and we got this beautiful one here that we captured. Thank you to our team who is behind the scenes watching that meteor camera for us while we are talking to guests, and we watched the ISS cam for a little bit, but we have a team behind the scenes that has been gathering these awesome things for us. So I'm loving seeing your excitement in the chat for this. Loving also seeing where you guys are seeing meteors from. I know that we've gotten a few from Texas. A lot of people are seeing clouds tonight, which is really unfortunate, but I'm glad that our clouds here in Huntsville have moved away so that we could capture that one. All right, with that being said, let's jump back into a live view of our meteor camera here. And again, if you are just joining us, welcome. We're having a watch party for the Perseids Meteor shower from NASA's Marshall Space Flight Center in Huntsville, Alabama. We've got a quick refresher actually prepared for you. This is a perfect Perseids 101 to give you a bite-sized breakdown of the topic of tonight's show. So I want to play that for just a little bit for those newcomers.
Perseids travel at about 133,000 miles per hour, 214,000 kilometers, which is faster than a bolt of lightning. Here are 10 more fast facts about the Perseids. Perseids are one of the oldest observed meteor showers, with records of them dating back 2,000 years ago. The Perseids are debris left over from the comet Swift-Tuttle, which the Earth travels through once a year. Swift-Tuttle is more than 15 miles wide. At their peak, the Perseids can produce up to 50 meteors per hour under dark, clear skies. The shower is called the Perseids because from a skywatcher's perspective, the meteors appear to radiate from the constellation Perseus. The Perseids are active for about 6 weeks, from mid-July through late August, and the peak happens when Earth hits the densest part of the debris stream. The Perseids are one of the most photographed meteor showers thanks to their brightness, frequency, and timing during warm summer nights. Each meteor you see is a bit of comet dust that's been traveling through space for hundreds or even thousands of years before hitting our atmosphere. Though humans have been watching the Perseids for more than 2,000 years, they were first recognized as an annual meteor shower in 1835. Although we see debris from Swift-Tuttle annually, the comet only orbits us about once every 133 years. It last passed through the inner solar system in 1992 and won't return until 2126. The Perseids are famous for producing fireballs, which are exceptionally bright meteors, but most of the particles creating them are smaller than a grain of sand.
All right, we're getting really close to the peak of the shower now, so this is a perfect time to settle in. Keep your eyes on the screen. Even though these particles are smaller than a grain of sand, they do put on a big show. If you spot one before we do, let us know in the chat. Here in Huntsville, Alabama, the peak of this meteor shower is a couple of hours away still, but it does seem like these meteors are livening up. We just got a really good one. So, Bill, what should people expect to see as we get near that high activity window?
Well, the rate of Perseids will pick up. So as we approach 4 a.m., you'll start seeing more and more Perseids as the radiant gets higher in the sky. So you will see the rates increase steadily over the next few hours, right up until dawn.
Awesome. I know your team has been working on a tool to be able to look up how many meteors per hour a certain location could spot during these major meteor showers. Now I'm curious, chat, could you tell us where you're watching from? We've got thousands joining from all over the world tonight, and I would love to know how many meteors your location will be seeing during the peak. So if you live in the US, put your zip code in the chat and we'll look up as a few of those and see how many meteors you could spot. We're going to grab those in just a second. We're going to give you time to put them in the chat. While we're waiting for those, I want to ask you a few questions, Bill. We do have a good question here about the ALaMO camera, actually, which is what we're looking at right now. How does the ALaMO camera distinguish between meteors, birds, satellites, and other objects like planes?
Oh, that's a very good question. Well, aircraft, for example, blink. Meteors don't blink. So our software is trained to look at things like blinking lights. Birds seldom travel in a straight line, so we can eliminate those. satellites don't move as fast as meteors, so we look at how fast the object travels across the sky, and we basically can eliminate satellites because they move slower than meteors. So our software has special conditions that have to be met for it to say this is a meteor, and it rejects other things.
Amazing. That's good information. All right, we have a lot of zip codes coming in. So, Bill, are you ready to take a few?
I am ready to take a few.
Okay, I'm going to pull one here from Amber Vix is at 72156.
72156. And according to the tool, 72156, at 4 a.m., Amber should be able to see 50 Perseids per hour if she's in
Ooh.
in a really dark place with a good clear sky.
Oh my goodness. That's amazing. Amber, you better go out and take some pictures and put them on social media. That's all I got to say. All right, we have Stubby Gator, 72543, said it's going crazy here. So I'd love to know how many meteors they're getting. 72543.
Stubby should see at 4 a.m. a maximum rate of about 40 Perseids per hour, so pretty good compared to here in Huntsville. So if he's got a good dark sky and a clear view of it, about 40 meteors per hour at 4 a.m.
Perfect. All right, let's take a couple more. Wendy is at 97862.
Nine, 7, 8, 6, 2. It would help if I did not make a typo.
Yep, 97862.
No, Wendy's in a really dark sky. She can see up to 52 Perseids per hour.
Wow.
Yeah, at 4 a.m.
That's awesome. All right, okay, let's take one more. I'm loving this. Okay. All right. Okay. Rowan 18252.
Rowan should be able to see about 42 Perseids per hour at 4 a.m. this morning.
Wow, y'all are seeing some good ones.
They're in good skies.
They are. All right, we've seen a lot of people at Sky Meadow State Park. I've seen this a lot. So Lauren has put in 20144, which I believe is the state park. I would love to know how many they're seeing. 20144.
At 4 a.m., they will see 50 Perseids per hour.
Okay, perfect. As many as Amber. All right. That was a fun little activity. I love that. This is such a cool tool for us to use. So thanks, Bill, for looking those up. As we get closer to the end of our show, I'd love to take a few more viewer questions. So make sure to put those in the chat. While we wait for those questions to come in, I do have a more personal one for you, Bill. What has been your favorite part of tonight?
Oh, that's a good question. I like talking to Peter and Amy.
Uh-huh.
It's always nice to talk to colleagues, and it's always fun to ask them questions.
Mm-hmm.
So I like that part. I always enjoy the ISS feeds.
Yeah.
Viewing Earth from space never gets boring.
I agree.
And to me, I always look at that and I'm like, will I see a meteor? Will I see a meteor? You know, so the ISS feed is probably my favorite view because I don't get to see that very often.
That's true. I loved it. It was a stunning view. But that's a beautiful answer, Bill. I will say I personally am really enjoying the shared experience we're all having right now. I know watching meteor showers alone and in silence is magical, but watching them with all of you, Bill, our viewers, our guests, it's just been an entirely different experience. It's fun, it's thrilling. I have learned so much from all of you. There's still more I think we can learn though, so I'm gonna grab a few more questions as we celebrate our Meteor Christmas here. All right. I've seen so many good ones. I might fire around you, Bill. Okay? All right. Ethan Leroy 948 asked, is this event rare? If so, how rare? Also, is it possible for it to happen several times a year? And finally, how do you manage to predict all of it?
Okay, so is it rare? No, meteor showers are not rare. The Perseids, for example, occur every year at this time. There's an even stronger shower, the Geminid meteor shower in December that happens, in mid-December of each year. And there are other meteor showers, so they're not rare. And the second part of the question was?
The second part was, is it possible for them to happen several times a year? Which
Yes, meteor showers happen very time. You get fewer meteor showers the first 3 months of the year, but starting in April with the Lyrids, activity picks up and it goes to January, and then it kind of peters out between January and April.
And then finally, how do you manage to predict it all?
Well, we have, like Peter Brown said, we put comets in orbits around the sun in computers, and we sling particles off of them, and we basically track those particles and see how many strike Earth, and that's how we generate our meteor shower forecast. So we've known how to do it since 1899. We just had to wait for computers to come along, and it wasn't until the mid-1990s that computers got fast enough for us to be able to predict meteor showers.
All right, I have another question for you from Rising Sun with a Z. They asked, do you have a camera that shows things in color, but there's a reason that these cameras don't. Is that correct?
Yes, so one thing you learn about scientific cameras is they're monochrome and boring. Okay? The reason we don't have color cameras is color cameras are less sensitive than monochrome cameras, so I would see fewer meteors with a color camera. And plus, a color camera has the Bayer matrix, and decoding the colors and stuff makes it a little bit difficult to do science. But, a common complaint is, why are you using a black and white meteor camera? Because that gives us the most data. It's not the prettiest picture in the world by any means, though.
Speaking of cameras, I don't know if you'll know this one, Bill. What's the square mileage this camera covers?
Well, looking up, if you assume that it's seeing meteors at the typical burn-up altitude, this camera covers about 10,000 square kilometers of sky. So it turns out I do know the answer to that question.
Ah, nice. People loved the tool that we were using, Bill, to look up their zip codes. They're asking, is it going to be open to the public?
It's in very beta phases right now. It's, we verified the calculations, but we got to pretty it up. But we hope maybe in a couple of months, maybe 3 months down the road, that it will be available on a NASA website for the public to use. Yes, that is the goal here. So people can punch in their zip code for a given meteor shower and know how many meteors they can expect to see at night. And it takes into account things like the brightness of the moon, if it's up, and how bright the sky is in that zip code.
I love that. I can't wait to use it myself, maybe for the Geminids, which are in December, I believe.
Yes. Yeah, the Geminids are coming up.
Awesome. All right, I got a few more that I just want to get through. So this next one asks, can we or will we ever discover a new meteor shower?
We discover new meteor showers all the time, but they're generally so weak in terms of number of meteors you wouldn't know they're there. We have camera networks, and they're finding new meteor showers, but the rates are like 1 meteor per hour or less. So you would never know they were there. They would be lost against the background meteors. But with our meteor cameras, we can measure their speed and their orbits and their trajectories, and we can say, hey, these guys are related. So the answer to your question is we're finding new meteor showers all the time. As a matter of fact, the International Astronomical Union database of meteor showers has something like 1,000 meteor showers in it.
Wow. That's awesome. I've also seen a few people ask, how old are these meteors? We talked a little bit about that with Peter, but could you touch on that again?
Yeah, so in the case of the Perseids, um, they're at least 133 years old.
Wow.
So they're at least 133 years old, probably several hundred or a few thousand years old.
Oh my goodness. That's crazy. All right, RedNat19 has asked, I've been watching the shower in Virginia and I've seen a few have a really bright flash with the trail remaining for a while. How come that happens?
That's what we call a persistent train. So that bright flash you're seeing is the meteor breaking apart, and that trail that persists are those particles gradually fading out after the meteor breaks apart. So you're seeing the little pieces of that meteor fading out behind it because the main meteor broke apart.
Hmm. This question actually goes really well with that one. Do the colors of the trains indicate what they're made of, or does it depend on the air?
It depends on the air and the composition. So you have, some meteors look green because they're ionizing oxygen up there. The Perseids, a lot of people say they look yellow because of sodium.
Ah.
And to me, Perseids look white, but I have terrible color perception, But I have seen green Geminids, though. I'm pretty good at spotting green.
Uh-huh. Yeah, I've heard the Geminids are easy to spot because of their green tails. That kind of also brings us into another question, also by Rising Sun with a Z. What are meteors made of?
They're made of little bitty conglomerations of dust and ice held together by an organic glue. So meteors come from comets, which are, thought to be icy dirt balls, and they're pieces of that. So imagine bits of dust and ice held together, and these things are very fragile. A lot of meteors are about as strong as a pinch of snow. So the minute they hit the atmosphere, they start breaking apart.
Oh, gotcha. All right, and then I'll ask you one more here. So Glenn has asked, do they always fall moving right to left? I'm assuming Glenn has seen them move right to left.
Yes, no, they can move left to right. They generally fall towards the horizon, though.
Mm-hmm.
So they can come from any direction depending on how high the radiant is in the sky.
Gotcha. Well, while we were taking some questions, Danielle with the ALaMO team has been in the control room grabbing a few of the best imagery from tonight. So let's pull a few of those up now and talk through them here. All right.
Oh, that was a good one.
That was a good one. Wow, Ohio's been seeing a lot, huh?
Yeah, these are from Ohio. This is from Florida.
Uh-huh.
The UCF campus again. Here's one from Embry-Riddle in Daytona, Florida. And this is from Tennessee, Tullahoma, Tennessee.
Yeah.
Another one from Ohio.
We've seen a lot from Tennessee and Ohio tonight.
Yeah.
Florida, yeah.
They had better skies than we did.
Yeah, we got that good one. That was
Yes.
a really good one we got here in Huntsville.
I think that was the brightest one we've seen tonight.
I do too. Is there any way we could pull back up the Huntsville meteor? That one was captured here from our Marshall cameras. We might have to come back to that one later, but I loved that one so much. I think this is our live view, but I want to see if we can get that Huntsville one more time. It was so good, I just have to see it.
No pressure on the people in the back room.
I know I put pressure on them now. Actually, while they're getting that ready, this question that we just got actually does really tie in well. Why are some meteors brighter than others, Bill?
And it's a function of speed and it's a function of size. Oh, yeah,
There
that's
it
so
is.
pretty.
It's so good.
It's great.
I love it.
So the faster a meteor moves, the brighter it is. Also, the bigger a meteor is, the brighter it is.
That makes sense.
So since the Perseids move at the same speed, if you see a faint Perseid compared to a brighter Perseid, the fainter Perseid is smaller than the brighter Perseid. Now,
Gotcha.
A Geminid and a Perseid of the same brightness, the Geminid would have to be bigger because Geminids move slower than Perseids do. So to produce a meteor as bright as a Perseid, a Geminid has to be bigger than the Perseid.
Mm-hmm. Awesome. Well, those were some beautiful shots, Danielle. Thank you for grabbing those for us. Now, before we wrap up, Bill, were there any moments from tonight that really stood out to you?
Well, the ISS feed,
Yeah,
that was the one. And I like that fireball very much.
I did too.
I'm going
I
to be
think
looking at its orbit and trajectory and its light curve and all sorts of nerdy things tomorrow.
awesome. I cannot wait. It looks like your team's going to have a lot of fun studying that one for sure.
Yes.
Well, I want to say the chat has just been lighting up with Christmas trees and hearts and, really celebrating this meteor Christmas that we're having. But tonight is coming to an end. It has been an incredible night, and we unfortunately are going to have to say goodbye. So we've watched the sky from Huntsville, Alabama, right here at NASA's Marshall Space Flight Center. We've watched it from the International Space Station. We've answered your questions, and we have had some truly awesome conversations about the Perseids, meteors, lunar impacts, planetary defense, the whole cosmic neighborhood. Before we wrap up, I want to take a moment to thank our Perseids tour guide for the night, Bill Cook, lead of NASA's Meteoroid Environment Office here at Marshall. Bill, thank you so much for staying up late with us, sharing your expertise, and walking us through everything from fireballs to lunar impact flashes.
Thank you, Alyssa. It was fun being here. A good way to spend Meteor Christmas, right?
Absolutely. Chat, let's show Bill some love. If you have learned something new tonight, or if you just enjoyed his commentary, drop your favorite space emoji in the chat so he could see it before we sign off. Bill, you're getting a lot of love in the chat. I'm seeing so many good nights and hearts and, oh my goodness. A lot of thanks are coming in. I'm seeing everybody put where they're from. Thank you. Good night. I love it. All right, now we may be concluding our YouTube stream here, but for many of you, the peak of the Perseids is still coming up, so please go outside if you can and watch for meteors yourself. Bill, do you have any final tips for viewers that may be heading outside after this?
Yes. Find the darkest sky you can. Take in as much sky as you can. Look straight up. And don't look at the cell phone. It ruins your night vision.
Perfectly said. Even though the peak is happening right now, the Perseids will be visible through August 24th. So if you end up seeing something spectacular, feel free to share it on social media. We love seeing your sky watching moments. And seriously, thank you again, Bill. We're going to let you get some well-earned rest now.
Thank you.
Now, to everyone watching at home, whether you have been with us for the full show or you've just recently hopped on, thank you. You've made this a truly fun and interactive night. Every question, every sighting you shouted out, every emoji that you sent, it all made this feel like we were truly watching the skies together. On behalf of NASA and Marshall's Meteoroid Environment Office, our International Space Station support team, all of our guests tonight, and of course our amazing team behind the scenes, thank you for spending your night with us. If you want to keep up with future skywatching events, check out NASA's Watch the Skies blog to learn more. I'm Alyssa Lee. Thank you for having me as your host. Have a wonderful night or morning for most of you. Happy sky watching, and we'll see you next time. Good night, everybody.